Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yeah, and we're definitely talking about a science topic and a space topic. And it involves a black hole and what this black hole did. So,
Today, a
here we
black
go.
hole shredded a massive star in a record breaking explosion. Probably should be in the Guinness World Records, Guinness Galactic Records. But what astronomers discovered afterward may be even more remarkable. Black holes are among the most destructive objects in the universe, but astronomers have now witnessed one carrying out an act of cosmic violence unlike anything seen before. A newly discovered event appears to show a black hole ripping apart a massive star, triggering an explosion so powerful that it surpassed every known stellar collapse explosion ever recorded. Would you like to know more?
Now, I would like to see that. That would be pretty fascinating.
Yeah.
Okay, the event, officially named AT2024WPP and nicknamed the Whippet, briefly released as much energy as 400 billion suns. That's incredible. That makes it far more powerful than a typical supernova and brighter than any previously observed explosion powered by the collapse of a star.
Researchers believe the outburst began when a massive star ventured too close to a black hole. The black hole's immense gravity stretched and shredded the star, drawing some of its material into a superheated disk. As the debris spiraled inward, it emitted intense X rays and drove a powerful wind into gas the star had shed before its final destruction.
Dana Purley, associate professor of astrophysics at Liverpool John Moores University and lead author of the study, described the scene at the American Astronomical Society's annual meeting. Didn't even know they had one of those. Quote, we discovered what we think is a black hole merging with a massive companion star, shredding it into a disk that feeds the black hole. It's a rare and awe-inspiring phenomenon, unquote.
Astronomers have seen black holes destroy stars before in events known as tidal disruption events. What makes the Whippet unusual, Whippet good, is its scale, speed, and brightness. It also belongs to a rare class called luminous fast blue optical transients, or LFBOTs, which flare brightly in blue and ultraviolet light and fade much faster than ordinary supernovae.
Okay, so what happens to stuff after it goes in the black hole?
Goes to another dimension.
Uh-oh. And who knows what's going on there, right?
Right. We think that black holes are wormholes to like other quadrants of the galaxy, but nobody's tested it out.
Wow. Like space quicksand.
Yeah.
Anna Ho, an associate professor of astronomy at Cornell University and a co-author of the study, spotted the Whippet soon after its light reached Earth using the Zwicky Transient Facility at Palomar Observatory in California. Within a day, the Liverpool telescope in the Canary Islands and NASA's Swift satellite confirmed that the object was intensely blue and producing X-rays. Wow.
Distance measurements from R. Michael Rich at UCLA and Eugene Kin at Caltech showed that the blast was far too energetic to be a normal supernova. Its extreme heat and fast evolution pointed instead to a star being shredded and swallowed by a black hole.
So is this one of those events where there's somebody sitting at home or sitting in an office watching their monitor or watching these views on some kind of a monitor, and as soon as this happens, they freak out and then they get on the phone and start calling people and saying, hey, you got to get into the office, you got to see this. Or maybe
I'll,
these guys have monitors at their houses, I don't know.
I'll bet you that some alarm starts going off, beep, 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 and they got to go over and say, oh my gosh, check it out. And then they get on the phone and start making the calls.
Yeah. Okay, another quote. Even though we suspected what it was still extraordinary, according to Purley. Going on with the quote, this was many times more energetic than any similar event and more than any known explosion powered by the collapse of the star. Wow.
Quote, not only do these events help us identify black holes, they provide a new way to identify where black holes occur and how they form and grow, and the physics of how this happens, Purley added.
Because these things are out there, right? I mean, you may not. What if you were? Let's say you were in a space capsule, and you were traveling to a planet like Mars or wherever. And I don't know, are these things all over the place? I don't know. I mean, it's kind of weird. But
Yeah.
what if you flew into one of these or it sucked you in?
Well, you go to the Delta Quadrant then, because we're in the Alpha Quadrant. Yeah.
I mean, if there's no way to get out of this thing. I mean, can you not get out of that? Is it like being in a vacuum?
No, it's the gravity is too. I mean, it captures light. That's how strong the gravity is. So you'd either be crushed into bits, or you'd be transported to another quadrant through that wormhole.
Wow.
Who knows?
Okay. The Whippet also revealed something astronomers usually cannot see directly: the hidden gas around a doomed star. A shock wave raced outward at about 1/5 the speed of light, plowing into dense material nearby before suddenly fizzling out after roughly half a year. Researchers think the shock faded when it reached the outer edge of a bubble carved by gas the star had lost before the final encounter. So exhaust.
Yeah, that surrounding gas helped turn the black hole's feeding process into a brilliant display. The disk around the black hole produced X-rays and a powerful gas wind, which slammed into the star's earlier outflows. That collision created the blue optical and ultraviolet glow seen in the first days, followed by radio and millimeter signals later on.
One of the strangest clues appeared only after the event began to fade. Early observations from Keck Observatory, Magellan Observatory, and the Very Large Telescope showed almost no recognizable chemical fingerprints. Later, weak signs of hydrogen and helium emerged. The helium was moving towards the Earth at more than 6,000 kilometers per second. That's pretty fast. About 3,700 miles per second. Wow. Suggesting that some dense structure survived the initial blast. Wow.
The team thinks this could be a stream of material pulled from the star's core as the black hole tore it apart. A more speculative possibility is that another object in the system, perhaps a third star, was blasted by the black hole's particle wind and X-ray radiation. Wow, it's just crazy.
Stay away from these black holes.
It's cool that they were able to witness it and see it. That's cool. Thanks to our strong satellites.
Yeah. But yeah, pretty scary if we're up there floating around.
Yeah.
I don't know. It's like looking for landmines, right?
Yeah.
Somehow figure out how to do that. So anyway.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
Take care, everyone. Thanks for listening.